Whenever we're solving and we have an x and the exponent, or we have equations with logs in them, we always want to start by simplifying until you get one and only one term on each side. So it might look like a power equal to a number, or maybe a log expression equal to a number, or maybe it's two log expressions set equal to each other. Either way, you want to have just one term on each side, and you might need to use some Algebra 1 techniques, adding something to both sides, dividing by something on both sides, or you might need to use some of the log properties that we covered in a previous slide. Either way, you want to make sure you get only one term on each side. So once we get one term on each side, there's basically two strategies to use depending on whether we're given an exponential equation or a logarithmic equation. So first scenario, we're given an exponential equation with x in the exponent. So first, we again want to simplify to get one term on each side. Then we want to use our inverse operations by taking the log of both sides. And you can do this by either taking the log of the same base, which goes along with what we've been talking about using inverse operations, or option 2, which I know is sometimes used, so I want to show it to you, is when we just use base 10 in combination with the power rule. Now, you don't need to know both of these options, just one. I just want to show you both just in case you run into both. Option 1 is my personal preference. It makes the most mathematical sense to me. So let's say we have the equation 3 to the x plus 5 equals 11. Notice that we have two terms on the left-hand side, so we need to get it to where we only have one term on each side by just subtracting 5 from each side. Now we have one term on each side. Notice that the x is in the exponent. So when we ask ourselves what's going on with the x is being raised as a power of base 3. So how do we undo that? We use inverse operations by taking the log base 3, and we have to do that on both sides to keep it balanced. On the left-hand side, I see that we now have log base 3, and we have raised x to the power of 3 as well. Those are inverse operations, which undo each other. So now we just have x. Remember, inverse operations undo each other, so we're left with what we started with. Now we could just put this into our calculator if we have a calculator that can change the base, or you might be asked to use the change of base formula to put it into a calculator where you can't change the base. If I were grading a test and you said x equals log base 3 of 6 and it was a non-calculator test, that would be the best answer for me. You would only really need to change it into that quotient of logs if you don't have a calculator where you can change the base. So the other thing that some people do is once they get one term on each side, they just take log base 10 of both sides. And you can do that just like you can add anything to both sides or subtract anything to both sides. It's a perfectly okay thing to do. The only thing is, since we're not taking the log of the same base, we're not really taking the inverse of raising it to the power of 3. So they don't really cancel each other out like they would if we had taken log base 3. However, what we can do is we can use our power rule to bring that x in front, then divide both sides by log of 3, and we get the same answer. It just isn't as pretty as our x equals log base 3 of 6, but we still get the same answer. And if what we're looking for is just a decimal answer, it doesn't really matter which method you use. So either method works, but method 1 I like because we're actually taking the inverse because we're using the same base. It's like adding 10 and subtracting 10, multiplying by 10 and dividing by 10. We immediately get rid of that base of 3 and go straight to x, and we get a nice expression. If we don't have a calculator, log base 3 of 6 is a much nicer, kind of cleaner answer than log of 6 over log of 3. Now, here's another example. Let's say we have e as our base. Don't let that throw you off. E is just a number, 2.71, blah, 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 blah. It's just a number. We treat it just like we did that base of 3. So we want to start by isolating that e to the x so that we have one term on each side. And here, we're just using Algebra 1 steps. We're adding 3 to both sides. We're dividing by 2 on both sides. using inverse operations to get that e to the x by itself and just a number on the right-hand side. Now we have one term equal to one term, and now we can use the inverse operation of taking the log on both sides. Now notice that we have a base of e, so that means we want to take log base e. And remember that the way we write that is with that ln. That means log base e. So what we have here is log base e of e to the x. We've now done our inverse operations and we're left with just x. Now, we could just take the log base 10 of both sides, which you will sometimes see people do, and you'll see that when we do that, we just have to use the change of base formula. The log base 10 does not cancel out that e because it's not the same base. It's like adding 10 and then subtracting 2. It's not going to cancel each other out. So what we have to do is use that power rule, drop the x to the front, then we can divide both sides by log base 10 of e, and we get this expression here. So notice it's a longer process, and again, the final answer you get is not as pretty as x equals natural log of 4, but when you put both of those expressions into the calculator, you're going to get the same decimal answer, so it really doesn't matter. Notice that if I took x equals natural log of 4 and I wrote it in my change of base formula, I would actually get log base 10 of 4 over log base 10 of e. So either way, it works. It's just that option 2, a little more work, doesn't make quite as much sense as option 1. So whenever we have an x in the exponent, we have that exponential equation. We want to isolate the exponential expression on one side, get a number on the other side, take the log of both sides, go from there.